Welcome to qnawire.
Okay, so we're starting out with our free particle wave function, which is from example 40.1. We have psi, let me rewrite that. We have psi x and t equals a e to the I k1 omega minus omega 1 t plus a e to the I k2x minus omega 2 t. We're given that k2 is equal to 3k1, which is equal to 3k. The probability distribution function, which is psi xt, the absolute value of this squared, is given in example 40.1. And that is given as 2 times the absolute value of a squared times 1 plus cosine of k2 minus k1 x minus omega 2 minus omega 1 times t. So now we want to solve for what k2 and k1 and omega 2 and omega 1 are in relation to just k and just omega. So we're given in the problem that omega is equal to h bar k squared over 2m. So we can plug in our k2 in order to find w2. So we can do that. This is omega, not w. So omega sub 2 equals h bar k2, k sub 2 squared over 2m. And we're given that k sub 2 is equal to 3k, so we can plug that in. And so now we have that omega sub 2 is equal to 9h bar k squared over 2m. But as you can see, this part here, let me quick rewrite this. You can see that's still a 9. The part circled in blue is equal to our original omega. So now our omega sub 2 is equal to 9 omega. Same thing to solve for omega sub 1. We want to plug in k sub 1. And our k sub 1 is just equal to k. So now we have h bar k squared over 2m. And this is equal to our original omega. So now we have omega sub 2 is equal to 9 omega, and omega sub 1 is equal to omega. So now we can start plugging things into our probability distribution function. So that, again, is psi xt squared equals 2 absolute value of a squared, 1 plus cosine. So the original one was cosine of k2 minus k1. But now we know that k2 is equal to 3k and k1 is equal to k. So we can plug that in here. So now we have 3k minus k multiplied by x minus, and now we can plug in our omega 2 and omega 1. Omega 2 is equal to 9 omega. We subtract omega 1, which is equal to omega. And that is multiplied by t. And so now what we want to do is plug in our t, which is given as 2 pi over omega So now we have psi x 2 pi over omega squared equals 2 absolute value of a squared multiplied by 1 plus cosine, and 3k minus k goes to 2k, and that's multiplied by x, and subtracting 9 omega minus omega, which goes to 8 omega, and our time now we can plug in as 2 pi over omega. So now we can continue to simplify this. So we can set this equal to 2 absolute value of a squared, 1 plus cosine of 2kx minus, and we can see in this above equation that our omegas are going to cancel out, and we have 8 multiplied by 2 pi. So this goes to 16 pi. And the question is asking, when is our probability distribution function going to be a maximum? Well, this is going to be a maximum when cosine is equal to 1. So now we want to do a side equation where we find when will cosine be equal to 1. So we can do the inverse cosine on each side and find that we get 2kx minus 16 pi equals the inverse cosine of 1. The inverse cosine of 1 goes to 0. And so now on the other side, we still have 2kx minus 16 pi. And when we solve for x, we find that x equals 8 pi over k. And so the question was asking what will x equal to make the probability distribution function be a maximum. And so now we just found our answer. It is when the cosine term is equal to 1, and we used algebra to solve for the x, which is going to be 8 pi over k. So now this is our answer for part A. Moving on to part B, the question is asking what our average speed is. So in order to find average speed, we can recall that speed is our distance over our time. And our distance that we just solved for is 8 pi over k. And our time is still 2 pi over omega, which was given in the problem. So we can see that the pi's will cancel out, and then 8 divided by 2 will equal 4. So now on the numerator, we have 4 over k, and on the denominator, we have 1 over omega. We can multiply the top and bottom by omega, and we find that our average speed is 4 omega over k. And this is our answer for part B. And now we also want to compare it to the average velocity in example 40.1. So in that question, we had our average velocity is equal to omega sub 2 minus omega sub 1 over k sub 2 minus k sub 1. If we recall, our omega sub 2 is equal to 9 omega, and our omega sub 1 is equal to omega. Our k sub 2 is equal to 3k, and our k sub 1 is equal to k. So on the top, we have 8 omega divided by 2k on the bottom, and the average speed is 4 omega over k, which we can see corresponds to the average velocity that we just solved, the average speed that we just solved for part B. So they match, and that is how